So now in the substitution nucleophilic series of the reaction, the next reaction we're gonna deal is Benzyne mechanism. So in Benzyne mechanism is also known as Aryl mechanism. Now what is the condition of the reaction? If we talk about Aryl mechanism or Benzyne mechanism, what is the condition? Condition is should be an aryl halide. Okay, this is aryl group and this is halide group, and a strong base must be there, and with the strong base the beta hydrogen must be present over there. There should be a mandatory present of beta hydrogen. So we know what is beta hydrogen. So if we talk about this is alpha carbon, okay, the carbon directly attached to the halide, this is beta carbon, this is gamma carbon, this is delta carbon, so on we gives the name according to Greek alphabet. Now carbon next to the carbon directly attached with halogen is known as beta carbon, and the hydrogen is known as beta hydrogen. Okay, so carbon or hydrogen directly attached is known as beta hydrogen. So if we talk about KOH we know it is a strong base. So when it is a strong base, then there should be a strong base and temperature should be like very high. Temperature should be 300 degree. Now what happens in that case? The OH minus place that takes this, because OH minus is again a strong acid, okay, strong base. So we need a strong base over here. Now we know OH minus will attack over here. When OH minus will attack over there, then there should be the presence of acid. So we know the most acidic hydrogen is the hydrogen just present next to halide, because when this halogen is present next to halide, after removal that hydrogen, what happens, this negative charge comes here and there is a removal of Cl minus. So this is known as benzyne. This is the reaction intermediate. This is known as benzyne, or this is also known as aryl. Okay, aryl. So this is the intermediate. This is the reaction intermediate. Now we know in reaction intermediate, now this is the reaction intermediate, the name is benzyne, that's why reaction is known as benzyne mechanism. So if we are giving the reaction condition as a strong base and very high temperature, so it is forcing the reaction to move towards the formation of reaction intermediate, which is benzynium. So we are providing the sufficient activation energy through this that it goes to benzyne mechanism. When it goes to benzyne mechanism, that's how it goes to benzyne mechanism, the removal of Cl minus. Now again we have a benzyne here. When we have benzyne here, and we have also the bases here. When benzyne and bases are here, so what happening, we know this is a isotope. Okay, here C14 we are using it as a isotope. Okay, so C14 we are using, this is the isotope carbon. The carbon generally means C12, but these all are where we are using the 14. So these are the isotope. So to check the position of reaction, we generally use the isotope. Okay, this is also known as, okay, so isotope effect. Okay, so if we want to check the position of the product, the position of the functional group in the product, so we generally use the isotope, so we can guide how the reaction is proceeding. So this is known as isotope effect. Okay, now this process is known as Dove's process. The formation of this is known as Dove's process. Now we know that we have a strong base present here. Now strong base have two substrate to attack over. Okay, if bond flip over this side, there will be a positive charge, there will be a negative charge. Now OH minus will attack on positive charge. Okay, now this we have aqueous, so in aqueous condition it takes H plus from water. Okay, so when it takes H plus from water, so it forms the product like Cl is substituted by OH. So it is known as direct substituted product. But if we say in this case, let's consider there is also the 50% chance, 50% probability that bond will open on this side. When bond will open on this side, again there will be a generation of positive charge here. Okay, here there will be generation of positive charge, negative charge, and here there will be generation of positive charge here and negative charge here. So OH minus when attacks on positive side. So we know that that again negative charge will be occupied by H plus. So this is known as sign substituted product. So two types of substituted product we get with equal probability. One is equal percentage. One is a direct substituted product and one is sign substituted product. So now let's talk about the condition. Now let's talk about the condition where there is no alpha hydrogen. Now we know like let's talk about this molecule. So we know we have a strong base or strong nucleophile. So this reaction, this could and we have an alkyl halide, or we have like we can say benzyne. Okay, benzyl. Okay, so aryl halide, or we can say alkyl halide here. So we know that reaction do not follow SN2 because again there will be no chance of substituting that Cl because of resonance stabilizing. There is no chance of formation of SN1 because again we know the nucleophile is strong and it is very difficult on the critical conditions we will need to break Cl bond. Now again it is also not possible to make a SNAR. So we know this reaction there will be, in this case there will be no reaction. Okay. Now if we talk about like this example, okay, now we are taking this example. So first of all I'll encourage you to pause the video and answer by your own. What could be the possibility, what could be the structure of A, B and C if we are getting a product where A, B and C we are getting in the ratio 1:2:1, where B is 50%, A and C are 25%. So just pause the video, just think by your own, just see the reaction again and try to figure out the answer. So now if you see we have NH2 and we know the temperature, it is the reactant is ammonia also, and it is a very high temperature. Okay, now if we have the reactant K plus NH2 and this the substrate and reactant Cl, and this is so this NH2 minus we know high temperature and very basic condition, it encourages the Benzyne mechanism again. We know so NH2 will occupy. Now we know that NH2 may react by this side and it also may react by this side. So when it will react, let's name it A, that small a, and let name it small b. So we know when it is small a, so it is the product of small a and it is the intermediate of small a. It is intermediate of small a, it is intermediate of small b. Now there is a lot of chance of ammonia. So ammonia to attack over here. So when ammonia will attack here, there is 25% chance, and when ammonia will attack over here, there is 25% chance. When ammonia will attack here, again 25, again 25. So if we see the position just next to ammonia here, if we talk about here alpha carbon, if we take C14 as reference, then alpha carbon is occupying 2 times. So that we name it, and then we can name it as B, and this is A, and we can name it C. So B where it is getting 50% chance, and A and C where it is getting the 1/4 chance, it is 1/2 chance. So again we have another reaction. So same condition here with high temperature. So I'll ask them, we have to figure out the most stable product. What is the most stable product? So again I'll encourage you to pause the video, see the reaction and go into mechanism and try to figure out, try to find what is the most stable product. Now I see that this we have again all the condition which match exactly with Benzyne mechanism, Aryl mechanism. So NH2 will gonna replace a Cl minus here. But how it will replace? It is a very strong base, it's gonna take that, and due to high temperature there will be a formation of Benzyne mechanism. Okay, the Benzyne intermediate reaction. So this is the reaction intermediate Benzyne. Now we know we have ammonia over here. Okay, NH3, NH3 lone pair, it is gonna attack either on this side, on this side. So let's name it again A reactant and A side, and it is B side. So it is A and it is B. So when it's gonna attack on A, if we go through A path, so in A path, that NH3 will having that NH3 plus will be there. Now here what effect it is observing? Okay, so we know CS3 has plus H effect, or we can say plus I effect. So here we will be countering only plus effect. Okay, plus I effect. NH2 also is having plus I effect. So CS3 is having plus I effect, and NH2 is having plus I effect. Okay, we are countering only plus I effect. So we know in plus I effect, when it is plus I, now see again, this is a minus I, NH3 minus, it is a minus I, again it is showing minus I, and it is showing plus IH and plus I. Okay, again it is showing plus H and plus I. So we are considering the plus I effect. So now if we compare between A and B, we know that NH3 has in both sides negative charge on its para position. So what is the thing that is making the difference? So we know that the effect of NH3 plus is same on the both sides, but the difference, what the difference is generating, the difference that is generating is CS3. Here the CS3 having para position the negative charge, and here CS3 having the meta position on negative charge. So we know which reaction intermediate is most stable. So now if we consider that if only minus I effect, we gonna consider here plus I effect. So plus I effect of CS3 methyl group, it is far, the negative charge is far from methyl group. Here negative charge is closer than this, than A to methyl group. So when it is closer to A than methyl group, so here we know the plus I effect reduces the stability of minus I. So far more better. So it is more stable intermediate. So when it is more stable intermediate, so this gonna be our stable product, which is proceeding through more stable intermediate step. Now there is one more important step we need to consider over the reaction here. Then when it's formed, it follows the next step. So the H plus that coming from it is going from here also, here only. So here in the final product that is forming, it may also check by isotope effect. It may put any isotope and it may ask what are the product. So here it will be H. That H comes from that intramolecular reaction. So we know that intramolecular reaction are very faster than intermolecular reaction. So it is intramolecular acid base reaction. So here we have one more example. So this example again I'll encourage you, pause the video and try to solve by your own. Now if we see again the reaction conditions, it is clearly a Benzyne mechanism, Aryl mechanism. So H plus, so this NH2 will attack over here, it will take H plus and Cl group will leave from here. So it is a formation of Benzyne here, the reaction intermediate Benzyne formation here, and we know that CH3 CH3 we are considering minus I effect. So again it is very important that why we are considering minus I. Only we are considering minus I, but not plus M. We are not considering here plus M. Now we are not considering. That is very interesting factor, that it always we consider plus R group. We give the preference of plus R and plus H above the plus I, the inductive effect. Okay, so why here inductive effect? Because it is not in the chain where it is going in the resonance. The negative charge we see, it is negative charge formation by hybrid. Okay, again it is now it is sp2 hybridized. Okay, it is formation where it is a sp2 hybridized. Now when it is a sp2 hybridized, the resonance is not making any effect over this ion. Okay, so that's why we are considering here minus I but not plus M. So it is stable here. We know that it is stable here because when we are considering minus I, so it is stable here. Okay, when it is stable here, again there will be a intramolecular proton transfer. Okay, so there will be a intramolecular proton transfer here, which is very fast than intermolecular proton transfer. So the final product we are obtaining is when the ammonia group is at the para position, which is known as direct substitution.